Greetings, math friends. Let's say that you are a space explorer and you find a new planet. On the planet, you have different land masses. And on these land masses, you are going to count the alien species that you find here on the planet. So perhaps on this landmass here, we have 7 million people. Maybe on this other landmass, you have 6 million people. And then maybe on this final landmass, we have 5 million people. So it would be easy to say what the entire planet's population is. We can just add 5, 6, and 7 up. And we can say that we have a planet population of 18 million inhabitants. We have lots of zeros. It takes lots of space to write this. One alternative to this would be what we call the scientific notation. So we can rewrite the 6 million as 6 times 10, and then count your zeros. 1, 2, 3, 4, 5, 6. So we have 6 times 10 to the 6, and if you multiply this out, you should get back to here. Over here, we would do the same thing. This is going to be 7 times 10 to the 6, and then down here, this is going to be 5 times 10 to the 6. And then up here, we're going to do something slightly different. One thing I haven't mentioned about scientific notation yet is that you want a leading single number, and then since we have two important numbers here, in a science class you would call these significant figures. We only want one term in front of the decimal, and then other significant figures follow the decimal. And instead of using some like fancy division or multiplication, we are just going to count. If you look at this, there's an implied decimal point here at the end, and we're going to count to the position that we want. So 1, 2, 3, 4, 5, 6, 7. So this is going to be 1.8 times 10 to the 7th power to represent this number, which is our world population, as scientific notation. So then we would have that the sum of this number plus this number plus this number is equal to this number. The question might then become, well, if you know the scientific notation, is there a way to get directly from these numbers to this number? Let's explore that. If we list out these, let's just use the first two continents here. 6 times 10 to the 6 and 7 times 10 to the 6. And we add those up. If we add the first two numbers here before the multiplication, that's 13. And notice that these are the same things being multiplied by this. We actually leave those the same for right now. So we would have 13 times 10 to the 6th. But we notice that we set up here, there was a rule that you wanted a decimal point between these two numbers. So the decimal point is here right now, and we're moving backward 1. So we're going to add one number to the 6 to have 1.3 times 10 to the 7th. Now we're matching this number, and we're just a little shy, but we haven't added this number in yet. And before we get to that, I want to talk a little more about what's going on in what I did here. I said you could add these and keep this the same. Why would we do that? Well, let's rephrase this as distributive property. We know that we have this times this and this times this, which these are the same number, and we're adding this together. That's the same as saying 6 plus 7 times 10 to the 6. Distributive property would bring this inside here and give you 6 times 10 to the 6 and 7 times 10 to the 6 added together. So when we write this and we add the first numbers and bring down the second numbers, this is actually a hidden form of the distributive property, which we've probably known for quite a while. So that brings us into the next question of how do we add this in? Well, if we were adding all of these together, we're going to reset this a little bit, and then we'll come back to this step. All right, we've reset this a little bit, so we have our 3 continents that we're adding together. Again, we can just add this column, and all of these are being multiplied by the same 10 to the 6th power, that same value. So we're going to end up with 18 times 10 to the 6. I just add these numbers together and I carry this down. This is still essentially the distributive property, but we've expanded it slightly. If we rewrite this as 6 plus 7 plus 5 in parentheses and put 10 to the 6 on the outside, we would distribute this 10 to the 6 inside and get these values to add together. So we've just added an extra term inside the parentheses with the distributive property. Now that we've done this, we see there is no decimal point visible here. We need to move from this position to this position. That's one position. So we're going to add 1 here. We're going to end up with 1.8 times 10 to the 7th, which is the number that we got up here when we added these numbers together and then converted to the scientific notation. Now let's talk about comparing. Let's take a look at this continent right here, the 7 million people. We can see the 7 million here, the 18 million here, and we can find out size differences. We can subtract the 7 million from the 18 million and see a size difference. Can we compare directly the scientific notation and this? Well, we notice that the 6 and the 7 are different. These are called magnitudes. So this magnitude is 1 larger than this magnitude, which tells us that this is a much greater number than this. But by how much? What you can do, if you have to compare these numbers together, it would be easier to be able to compare the first numbers if the second numbers match. Well, how can we do that? Well, notice that how we got to here was here. You can reverse that process if you need to think about how these numbers compare. So if we move the decimal point back here, we end up back here. So this is 18 times 10 to the 6. Now this isn't officially scientific notation at this point, but we're working through a problem, so we're on an in-between step. So now we can look at 7 times 10 to the 6, and we're going to subtract these, and we find that we have 11 times 10 to the 6. If we would have taken 7 million and subtracted it from the 18 million, we would have had 11 million. So that all works. So now we kind of have this apples to apples comparison that we can do. Everything is times 10 to the 6. So we see that we had 7. We're looking at the world population, and it's 11 bigger than 7. So it's 1 times 7 is 7. 2 times 7 is 14. So it's somewhere between a 1 and a 2, right? So it's a little over that. You might say 1.5. If we took 7 times 1.5, What does that give us? Well, we can do this math real quick. This is 3/2 as an improper fraction. This would be 7/1 as a fraction. And then we can multiply these together. So we have 21/2. And then 2 goes into this 1 time. 2 goes into 1 0 times. And we end up with 10.5. So that's really close to 11. This would round up to 11. So the world population is approximately 1.5 times the continent population. And we got that by comparing this number to the difference between the world population and the continent here. So this times some number gets close to 11. In this case, we kind of guessed, because it's between 1 and 2, we guessed 1.5. That got us really close. With rounding, that gets us where we want. So you can make an estimate that the world population is 1.5 times bigger than this continent's population. So not an exact answer, it's an estimated answer. And sometimes we're asked for estimated answers when we're given problems. They say approximately how much bigger is the world population from the continent population, or estimate how much larger the world population is compared to the continent population. So we see estimate and approximation come in. If they want to know exactly, well, then we're going to have to do some division and find exactly what fraction is going to work to multiply by 7 to get us the 11. And it's going to be close to 1.5. But an exact answer, we have to divide. So you take 11, divide by 7, and that's going to be your solution there. If you're looking at the difference of the world population from the continent population, for a final answer here, since we've done the subtraction, again, we have to move the decimal point 1 unit backwards, so that we have 1.1 times 10 to the 7th is the difference in the world population versus this particular continent. So with scientific notation, we always want one decimal place in front and all the rest of the numbers that are significant following that decimal. Multiplying and dividing is a different process. That would be a topic for a different video at this point. Hopefully you find some mathematics in your part of the world to explore and enjoy. Share with others. Cheerful Calculations.